the periodic table. Now there are a bunch of elements in the world where different substances. There's gold, there's silver, and also bronze, which would be when copper and tin together, that is bronze. So a bunch of substances. Some can be put together like copper and tin, that becomes then bronze. Or just gold or silver or platinum or something else. All these elements, they have to be sorted, and 109 are known in this book when this book was written. A few found since then. A few were found since then. Now, these 109 elements, they have to be sorted. They have to be sorted in some way. And the periodic table is the way to do it, which is a way which is often used to do it. And there was Dmitri Mendeleev, and in 1896 he published his idea how to sort them. He took every element which he knew about, without all the information down on the card, sorted them and published it then, and that was his result. So all the elements down, 1, 2, 3, 4, 5, 6, and so on, all the elements, 109 down in these lists. These lists are the periods, and that are the groups. It's like that. And they all have similarities, and someone who understands, is like that written in the book, how they are sorted there, can, by just looking at where they are written, know something about how this element will behave alone or with another one together. And now it is like that. There are different groups. There are the alkali metals, and then the alkaline earth metals, the transition metals, the lanthanides and austenites, and then the poor metals, the semi-metals, and the non-metals, and the noble gases. So all these groups. And they behave almost all similar if they're in such a group. So if someone understands it, they know it is written in the first group or the second group, that element will behave like that. It will burn at that degree, it will make then fire, it will react with other thing strongly, it will make something, it will shatter, it will make it going away, so it will make a solution out of it. How it will behave, basically. What will it do with another stuff? Will it be just peaceful there, or will it react? And for example, all these metals together, they have something similar things. Metals, they are solid at room temperature, a part of mercury for some reason. So solid, they conduct heat good. That is why if someone touches a metallic thing, it feels cold because warmth is going fast away. And other things, they are not like that. It goes not so fast away. Air, for example, is gas. And gas is not transporting the heat so fast, and also does not conduct the electricity so good. But metal does, and that is why cables are out of metal and stuff like that. So someone who understands it knows metal stands there and there and there, and they know out of that could be done a cable, or that stuff will react together with that, and so on. So something's there. How they are written there? Where is then written for carbon, for example, is 6 at the top, and then the C, then carbon, and then 12. The 6 means it has the atomic number 6. So someone could say atomic number 6 is carbon, or carbon has the atomic number 6. And that means that carbon is the 6th element in this list. There's 1, 2, 3, 4, 5, 6 somewhere there. And that 6 is the amount of protons in the nucleus. Such an atom has in the center of the nucleus, and then around it, shells, called like that. I don't think they're actually existing, but it's just called like that, shells, and on these shells are the electrons. So such an atom looks like that. In the center there is the nucleus with a proton in it by the atomic number carbon, 6. And then out of them, on these shells, however that now actually looks with these shells, there are now 6 electrons. So the same amount of protons has such an atom as electrons. And atomic number 6 says 6. Gold has whatever, 64, whatever. That means now 64 protons are in there, and the lead has 79 or whatever, and there are now 79 protons in the center and 79 on the outside. And these shells were starting like that. They're first a shell of 2, and then there are 2 electrons are on it. So that is for hydrogen. Hydrogen has the atomic number 1, and then helium number 2. Hydrogen has now 1 proton in the center and 1 electron then on the shell. Helium has now 2 protons in the center and 2 on the shells. And that is why we are so far apart written, because the shell is already full. I think that is the reason. So it doesn't look completely like rows, because these shells are differently. The first shell can only hold 2 electrons, the after ones 8, and probably even more. And so they're not written like 1, 2, 3, 4, 5, 6, 7, 8, or 10, so 1, 2, then 3, 4, 5, 6, 7, 8 or something like that, and then more or less like rows. And all the one in the first row, they have 1 electron on the outside. And the last row, there they have 8 or full. It wasn't said directly in the book. They are the electrons been full on the shells. Now, and that has a lot to do with how they react. Some electron with one on the outermost shell. If there's 1 electron on the outermost shell, that can easily react with another substance as if there were 2. So it has an influence how many are on the outermost shell, because that electron can be lost or gained. 1 electron can be gained to an atom and lost. So where they are, tells them how they are reacting, because all the one in the first row have one electron on the outside. That one electron, which is there on the outermost shell, so there's the nucleus with all the protons in it and neutrons also, and then all the electrons on the outermost shell, and all elements in the first group have one electron in the outermost shell. And therefore all these atoms in the first rows, these alkaline earths, have a similarity how they will react with other metals because they have one electron there. It's like a puzzle piece. That puzzle piece will fit together with south one who has 4, 3, 5 or 6 electrons in the outermost shell. And we're going always up. Every one further, one group further, or one row further, it's not said so directly here, as in one more. So one electron outermost shell, 2, 3, 4, 5, 6, 7, 8. So that is why there can be something read about how it all works. And maybe some interesting fun fact would be, the more protons are in the center, the more we're pulling in the shells. So actually the amount of atoms increases down the period with 15, 16, 17, 18, 19, 20 and so on, but the atom decreases in size because there are no more protons in the center pulling in the electrons on the outside. As a little fun fact. Now, and that is according to Susan McKeever's Science Encyclopedia book, written on page 32 and 33. Hi, back. I'm trying to learn chemistry. Today, the periodic table, and after we've done that, we're gonna do tiptoe yoga. And if you participate in the tiptoe yoga, then it's better honors. And this is the second part. We've read that part, I think, and I was reading a little bit here. Groups and periods. How does the periodic table work? The 109 known elements are arranged in horizontal rows, called periods. So these are the periods. The atomic number goes up as you move across. 1, 2, 3, 4, 5, 6, 7, 8. The periods start with an alkali metal on the left and end with a noble gas on the right. So alkali left, noble gas on the right. The atoms of the elements on the left at the beginning of each period have only one electron in the outer shell. At the end of the period, the outer shell is filled with 8 electrons. So 1 electron on the outermost shell, then 2, 3, 4, 5, 6, 7, 8. The vertical columns, so they're called groups. So these are the periods, these are the groups. Each contain elements that have the same number of electrons in the outer shell. The atoms of the element on the left are at the beginning of each period. The beginning of each period have 1 electron in the shell. By the end of the period, the outer shell is filled with 8 electrons. The vertical columns, called groups, each contain elements that have the same number of electrons in the outer shell. So the period starts in the first part, and the next period starts again with the first. And it starts always with 1 electron in the shell. And that way, we're having always in the first row the ones with 1 electron in the outermost shell. So they have the same valency and behave in a similar way chemically. They behave in a similar way chemically because they have 1 electron. And now it is, I think I can formulate it that they having the strength basically of 1 person alone. They are fighting to not be taken away. So that 1 single electron can be easily snatched away. And therefore all the one on the left are easier reacting, I think. That is it. And then further to the right, there are more of them, so they are not so easy reacting. Or maybe that is not the thing. Maybe they're reacting equally, similar or something, but they're reacting in a similar way. That is maybe more accurate. It's also easier to formulate that. And not so specific formulation. The point is they are reacting similar because they have the same amount of electrons. It is then equally similar or similar to remove electrons. If there are an atom which is free on the last shell, reacts similar to another atom with free on the last shell, because taking these 3 electrons away, or these 3 electrons fit together with another element which has 5 there, and then these 3 and 5 put together to become 8 and now a full shell. So all the electrons with 3 are reacting easier with electrons with 5. And all the 5 all the one with 5 electrons on the last shell have something similar, but they all like to react with one of the 3 group. It is something like that along the line. I don't know it all exactly, but it's the idea behind it. Metals and non-metals. Most of the chemical elements are metals, actually. So most of them are metals, so they say. The non-metals are in a triangle on the right of a periodic table. In a triangle, so 3 angles on the right of the periodic table. And was wir hier denunziert. Between the two are the semimetals, which have some properties of metal and some of non-metals. There are several big differences between metals and non-metals. Metals are solid. One exception is mercury, a liquid. So metals are solid. Metal, things out of metal are solid. That makes sense. And they conduct heat and electricity well and usually have high melting and boiling points. Now, out of metal there are things like steel and so on. So these things, and they all can conduct electricity. And they have high melting and boiling point. If someone wants to melt steel, they have to heat it very high. They form positive ions, cations, when they bond with other elements. So these metals, they are becoming positive ions, and an ion is someone who has lost electrons. And if they have lost electrons, they are more positive because they have no protons in the center as electrons because they've lost some electrons, and they are then called cations. And when metals are forming with other things, they become positive ions called cations. Most nonmetals are gases with low melting and boiling points. They are not good conductors except for carbons. The air is not conducting good, the air is a gas, the air is not conducting good electricity. But metal is dangerous, if it is similar to electricity. They form negative ions, anions, when they bond with other elements. Because we're getting some durability, and I think I know why. As I just said, the group 3 on the left side, the group 3 wants to come together with group 5. And if we come together, or something like that, the ones are getting 5 electrons, the other ones losing 3. And the ones who lose electrons are the ones further left on the periodic table. And the other ones lose. So we just have the basics of the periodic table. So what is our exactly? Let's maybe not go exactly, just stay with the basics to understand the periodic table, not exactly all elements. The more on the right side, they are losing electrons and are then positive. Must we not be negative? Because, oh, whatever, it is working together somehow. The number of electrons for each element is the same as the atomic number. So the atomic number is equal to the number of protons in them and the number of electrons on the shells. Sodium from group 1 has 11 electrons, so number 11. There's 11, but there's no sodium. Sodium from group 1 has 11 electrons with 1 in its outer shell. 2 on the first shell. The first shell is different. The first shell is 2, and then always 8. The second shell is 8, so 10, and then 1 on the 11, on the third shell, the 11th one. But where is sodium? Okay, magnesium. Let's take another one. From group 2 has 12 electrons with 2 in its outer shell. So there's magnesium, 12. I still don't get it. There's 12. This is 12. Aluminium from group 13 has 13 electrons with 3 in its outer shell. Aluminium 13, there we have it. So aluminium is group 13. How do they count? Silicon from group 14 has 14 electrons with 4 in its outer shell. How do we come to 14? Why is the group equal to the amount of electrons? The vertical columns are called groups. There's the 11 sodium there. There's the sodium. And now we have group 1. So that is group 1. That makes sense. Magnesium is then here, group 2, that is also here. And then aluminum is group 13 electrons. Why is it group 13? Are there so many in between? Silicon 14, that makes also sense. Phosphorus, group 15, has 50 electrons, so 5 in its outer shell. Phosphorus, that is here, 50. How do we come up with group 15? Because we count like that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Sulfur group 16, 16, chlorine 17, 17, and argon group 18, 18. 8 in the outer shell. Okay, the groups are actually not the colors, the groups are completely each line. So this is a group, this is group, this. If you have them all together, we come to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 aluminum. Is 13, 130. But also here gallium. Gallium is group 13 and 30. Group 13, but with 31 element. And it has now a total of 31 electrons. So actually every single group 1, also the one in the middle, are a group. So there are 18 groups. Across a period. Going across a period, the number of electrons increases by 1 with each element, and the chemical properties of the elements show gradual change. In period 3, the elements change from the metal sodium through the semi-metal silicon to the non-metal argon. The elements change from forming cations to forming ions. So period 3, 1 to 3. Natrium, magnesium, and then directly over to aluminium and silicon. Why no one in between? Because they say that aluminum is directly changed from metal sodium, completely on the left, through silicon to argon, because there are not so many in the middle, do we say? So because we want to list them in their groups, in their vertical lines, that is why we have them then here. Aluminium to have here could work because it's the 13, but then it would be over all these elements, and that isn't the case. It is that silicon is a semi-metal, and they wanted the semi-metals all together on that side. That is why they have brought them all up. Decreasing size. The number of shells remains the same across a period. But as the number of electrons increases, the size of the atom decreases. The number of shells remain the same across this period. So that has 1 shell, 2, 3, 4, 5, 6, 7 or something shells. Lead has 6 shells. So somewhere here must be their lead, 6 shells. But the size of our whole atom decreases because there are also now in lead 82 protons in the center, putting the electrons closer. So like more of them are there and they're putting the other one in. That is why the heavier the heavier the atom gets, the more protons and electrons in it, the smaller the atom seems to get. And that is why gas is so big and other ones are so small. And that is why some metals are so heavy if they are so tiny. So gas is so light because it is so big, and other metals are so much smaller because they are much smaller, the atoms. We're at least onto something. Now, we have all the rest almost at both papers. If you were here for chemistry, you can go directly to the next part where we're going to read the rest, and then we start to prepare a little presentation as an overview how the periodic table works, all the things based on the things which we understood. If you stay here and participate in our tiptoe yoga, 2 minutes, then it's headed honestly. Have a feet sitting together, really finish the arms up and come up onto tiptoes, out and down, and try to come always to the big toe with the weight. In and up, out and down, in and up, out and down, in and up, and out open to the side. in and up, out to the other side, in and up, and out to the side, make an inch of space between the toes, in and up, out, sink, bit down, keep staying on tiptoes, in and up, out to the other side, heels down, in and up, out a bit down, in and up, out and down, and in and up onto the toes, and out, sink down. This can go onto the knees. In and up, out and down. One more time, in and up, out and down, in and up, out, feet together, down, bend the right leg, and breathe out and stretch the left leg. In and change, out, stretch the right leg. In middle, hold both legs at the same time. Open the feet, and breathe in. Out the outer one leg. Breathe in, and out the other leg. Breathe in, out into the middle. Close the feet again. Breathe in, and out comes slowly with the round leg up, leg at the top, backward shoulder round. Breathe in the arms up. Out and down. That was a short tiptoe yoga. I thank you very much, and until next time.